Okay, so we are essentially in this part of the well here, we have two-phase. Why? Because we are past our flush point, which is somewhere in here. And we're flowing further up the well. Now, as we're flowing further up the well, we're dropping the pressure even more, which means that there's pretty much no chance that we're going to go back into liquid. What we're going to see is even more bubbles forming as we go up. Now we reach the wellhead, we're dropping the pressure even more, okay? So what is the phase of our fluid on the top side? Well, two-phase, of course. So we have flow of liquid, and mixed in with that we have vapor. And that will reach point 3, the entry to our separator. So let's go and take a look at this process, what we just saw here, and take it to the TS diagram, see what that looks like. So we're going to start off somewhere up here, and I'm exaggerating this distance just for the purposes of demonstrating this example. And I'm going to drop in here and go to point 2. So where are we? Point 1, production reservoir. Point 2, wellhead. Okay. Now, what about point 3? Well, we said that point 2 and point 3 are connected with surface pipes. Those have no effect on it. So essentially, I have point 3 here as well. Point 1, I'm inside the well. And what I'm doing is I am dropping my pressure and my temperature while keeping my enthalpy constant. So this line that I follow is a line of equal enthalpy. If you look at, if you Google the TS diagram, you'll see that it consists of a variety of lines, and some of them are lines of equal enthalpy. So I reach this point. Now this point, what's going on? I am touching this line. What's this line? So I'm touching this line, and we said this line is the saturated liquid line. Any further drop in the pressure will result in my properties entering the two-phase zone. So here we got two-phase. This is actually a flush point. Okay, it's this one here, these two. It's right on the saturated liquid line. I'm past this point, I'm dropping my pressure even more, and I reach a stage where I'm to the wellhead, and this is where I stop. Okay, we said no effects of the pipes, so that would be equal to 3. Now let's see what happens. Let's go back to the diagram and see what happens there. So let's continue on with our system description. I'm at point 3, and this is my separator. Inlet to the separator, more specifically. What happens? Well, I have two-phase fluid, it's flowing into it, right? And the liquid part of it actually accumulates at the bottom, while the steam part of it accumulates at the top, and it finds the path of least resistance, where it takes it and is directed to the turbine. This is point 5, this is point 4. I'm going to change colors to indicate that this is actually a liquid. Okay? I got liquid coming out of here, and I got gas, or vapor, sorry, saturated vapor coming out of there. Now let's take a look at the main assumptions that apply at the separator. As we said, the separator operates at a specific pressure. That pressure will be the pressure at both the inlet to the separator and also the two outlets to the separator. At 4, we have the water outlet, okay? So that's the water outlet. And the water outlet, obviously, the phase of the fluid will be liquid. But not just any type of liquid. The assumption when we're dealing with a separator is that whatever's coming out of it, whether it's vapor or liquid, is going to be saturated, okay? That's the key word here, saturated. So this is going to be saturated liquid. Similarly, at 5, this is the steam line coming out of the separator, okay? The phase at the steam line, I'm going to take this away and I'm going to add it here. The phase at the steam line would be what? Anton, saturated?
Liquid.
Vapor! Anton's not paying attention. Okay, so that's saturated vapor. Now I'm running out of space, so I'm going to have to start deleting some stuff here to make space to write things. So yes, I'll take all the little stars away. We said I put those little stars in here to indicate that the pipes have no effect on the flow. Please remember that as we go through it. Just because I'm removing it doesn't mean that it no longer applies. It does. I just need the space to write stuff as we go through the power cycle. Okay, so what do I say? I know what I said I need to know. I know the phase for both 4 and 5. One saturated vapor, the other one saturated liquid. I also know the phase for 3. Actually, I know everything for 3. What I need to know is the pressure, the mass flow rate, right? And the enthalpy. Looking at the enthalpy, right? I know it's saturated vapor or saturated liquid coming out of the separator. Since we're talking about saturated properties, if I know the pressure, then I can look them up using steam tables. Do I know the pressure? Yes, I do. Why do I know the pressure? Because of course it's going to be the pressure that the separator has been designed to operate at. Right? So the enthalpy, H5, for example, will be equal to Hg, because we're talking about saturated vapor, at P sep. Okay? While on the water line, the enthalpy, so H4, will be equal to Hf at P sep. Okay? Right. So I know the phase, I know the enthalpy, I know the pressure. Because P5 will be equal to P separator, will be equal to P4. What's left? The mass flow rate. Now I know the mass flow rate coming in is equal to m dot 1. What is m dot 4 and m dot 5? To calculate that, I need first to figure out what my steam fraction is. Remember the axis that we used in the TS diagram in the previous video? Let's go take a look here. Let's go transfer what we just did here onto the TS diagram. So coming back here, we have point 2 and 3, that's the inlet to the separator. What does the separator do? Well, it takes a stream onto the one side and another one right onto the other, right? So since here we have the saturated liquid line, this will of course would be the water line, so it would be 0.4, right? And this is the saturated vapor line, so that would be 0.5. Since at 5 the phase is saturated vapor. Okay, now as I said before, if I were to take normal projection to this axis, I will have x4 here, I will have x5 here, and at this point I will have my x of the separator. Okay. I've given you an equation to calculate x of the separator. Remember your assignment? You need to look at page 3 of 8. This equation 1 is what you need to use to calculate the x of the separator. And I will write it up here because we can see it on the video. Great. So x of the separator is equal to what? We have h of the mixture, right, at inlet minus h at the water outlet over h at the steam outlet minus h at the water outlet. Can we do that? Let's take a look. I'm not actually going to use values for this because you guys have done it already, but I will indicate what each of these correspond to in our diagram. Well, let's take a look at the mixture at the inlet, right? That h at the mixture in the inlet will be equal to h3. Do I know h3? Of course I do. I've already determined that's equal to h1. So I can write here h1 instead. All right, what about the h of the water out? Well, that would be h at 4. There we go. Do I know h4? I do, because I can look this up in the steam tables. I will have to go to where to find the row in the pressure column where indicates my operating pressure for the separator, and in the example that we saw, that was 7 bar. So you find the 7, you look for the HF, and you just read it off the table, and you're going to put it here, so that is also known, and it's equal to H4. Oh wait, this is also H4, because it's exactly the same thing. What about this one, H steam? Do I know it? Yes, I do. H5. Similarly, looking at the same tables, steam tables, I will look for Hg at the separator pressure. So that's also known, or I can look it up, so that would be H5. Perfect, which means that this is now a known quantity, right? So what do I need to calculate? I know that my m dot 3 is equal to m dot 1. I'm looking for m dot 5 and m dot 4. Well, m dot 5 is equal to x of the separator times m dot 1, because m dot 1 is equal to m dot 3, and m dot 4, mass balance, that would be equal to m dot 1 minus m dot 5. Easy peasy, right? Okay. Right, so we're done with the separator. I hope you guys can read this. Now let's move on and take a look at what happens in the turbine. Okay, so we're going to take a look at the part of the system that contains the turbine, inlet, exit, the condenser, generator, and the cooling tower. So we have saturated steam coming into the turbine, right? It's flowing through. Now this particular turbine is not open to the atmosphere, so it's a system that's sealed.